Okay, today I want to try something different to start this video. Today I'm going to give you a problem statement and that will be shown on your screens. I want you to just think about it, like how you will be approaching it, how you will be thinking about it. So, not the solution, just think about it for some seconds. You can also pause the video to think about it, and then we will get to this particular problem. So, I hope you have given a thought to this particular problem statement. I have taken this simple problem from the lead code, and this is the simple brief about this problem, what it is trying to say. That you are given with a sorted array, and you need to find the minimum speed at which Coco, the monkey, can eat all the bananas in exactly 8 hours. Now, whatever approach or whatever thinking you have made throughout this problem statement, uh, you just tell me that what do you binary search on, like will you be performing the binary search on the array. So you can also see from this problem statement that we are supposed to find the speed, like minimum speed. Okay, so based on that, if you think that you can perform the binary search on the array, so you can see that the array is the pile size here. The pile sizes are given in the form of array, so on that you cannot perform the binary search. Again, you can also think of that you can perform the binary search on the hours, so that is nothing but the constraint given to us. That is also we cannot perform the binary search on. So now, if we cannot perform the binary search on the array, we can also not perform the binary search on the hours. So what do you then binary search on? So if you just felt lost just now, that's good enough, and that's exactly where this video begins. And if you thought that wait, if you have given a little thought to the speed that we can perform the binary search on the speed, so that's good, because you just had your first instinct about the binary search on the answer, and by the end of this series that instinct will be automatic. So welcome, my name is Aditya, and this is video one of a series which I genuinely believe that this can change how the approach, that how you think about the problem solving forever. So it is not just for the interviews, not just for the competitive programming, but as a way of seeing the problems differently. So this is the pattern which is known as the binary search on answer pattern. This is the binary search on answer pattern. And here is my promise to you for this entire series, that I will never just show you a solution. I will show you how to think your way to the solution, starting from zero every single time. And you will just feel the pain of the brute force, like whatever the number of problems you will be solving, we will be starting from brute force, then going to the efficient version of it, that is the better approach, and then finally to the optimized one, which is nothing but the binary search on answer. You will be asking the right questions, and you will derive the answer yourself with me just walking alongside you. By the end of this series, when you see a problem that screams binary search on answer, you will know that how to approach it instantly, not because you memorized it, but because you understood it. So let's go. But before we go anywhere, let's make sure that we agree on where we are coming from. So let's just have a quick refresh on the classic binary search pattern, which is like a classic approach to solve any of the problems. So this is the pattern which we are going to see, that is binary search on answer. And now let's just have a quick refresh on the classic binary search. So what does the classic binary search pattern says? That we are given with a particular array, that will be the input array given to us in any of the problem, and we will be given with a particular target that we can say as a key. So let's suppose this is the array we are given with, and this is having some of the elements like 1, 3, 5, 7, 9, 11. Now we are also given with a particular target. Let's say we are having a target of 5. Let's say we are having a target that is 5, and for this target, now we are supposed to find that where it is present. So for that, what we can do, simple, we can just take a mid index, like with the help of left and the right pointers, we can take the mid index, and then we can start checking. So if the target is present at the mid index, then we can just return that index, that at this particular index our target is found. And let's suppose if this whatever the mid index we are having, if the element at that mid index is less than the target, then we should look for the greater target, and for that we will be moving our left pointer forward to the mid plus one. And same thing happens in the case when this the element at the mid index, if it is greater than the target, so we should look at the left side. In that case, the right pointer will be moving towards the left. So that's how the classic binary search works in this case. And when such things happens, like whenever we are eliminating our search space or eliminating the particular space where we have to find, so in such case the number of iterations which are taken, and that leads to O of log n. So that is the fact about the binary search approach. Now we can see here that what is the search space, like where we are searching. As we are given with this particular target that is equal to key, so we are hunting for this particular key in this input array which is given to us. So we can see here that the search space we are given with, that is nothing but the array. Here array is the search space and key is something which we are hunting for in this array. That is the search space given in this binary search approach. Now I want to do something different here. I just want to break everything you just agreed with. Like I am going to take a new problem here, and now see, when you see that particular problem, that's really it sounds simple at the start. So here is a problem we are given with, that we are given with a number n, and we have to find the square root of n, where we have to find the integer part only. So you can see here that n equal to 25 we are having. Now what will be the square root of n? That will be 5. If we are having the square root, like if we have to find the square root of n equal to 30, so what will be the square root of it? If we can try out with the possible values. So if we take 1 and we check if 1 is the square root of 30, that is not, because that is less. 1 into 1 it gives 1. Then we try for the another value 2, so 2 into 2, that is 4, which is again less than 30. Then we try for 3, that is 3 into 3, that is 9, it is again less than 30, it is not the square root. Then we check for the value 4, so 4 into 4, that is 16, it is again less than 30. Then we check for the another value 5, that comes 5 into 5, that is 25, it is again less than 30. And now when you move towards another value, that is n equal to 6, it gives you the square of 30, it gives you the square, and 6 into 6, that is 36. Now that is some value which is exceeding this n equal to 30. So you can't say that n equal to 6 is the square root of it. So what is the maximum possible value which you can say is that n equal to 5, that is the square root of 30, the nearest or the maximum possible value which you can see of. So we are having this n equal to 30, and we just start checking for values one by one, and the moment we got a value which is the maximum possible value less than equal to this 30 n, that will be our answer. So we have just seen the overview that how we are finding the square root. Now let's just talk about the approach, how we can solve this. So one is the brute force approach, which we always think of for any of the problem. So here the brute force approach says that you can just start with the values starting from 1, and then you can start checking the values from 1 to n, because obviously whenever you find the square root of any of the number, that square root cannot be 0, so that will be starting from 1. And another thing, that it can not be greater than n, so the loop goes from 1 to n, because the minimum possible value which can be the square root, that is 1, and the maximum possible value that which can be the square root, that is n. You cannot go beyond n, and also the square root can't be 0. So looping will be done from 1 to n, and which leads to O of n time complexity. And now you can also optimize it a little, like you already know that whenever the square root of any number is found, that will be the root of n. So that loop we can run from 1 to root n, and in that case the time complexity will be a bit efficient, that is O of root n. So this is what we have seen in a kind of brute force approach, that how we will be approaching it. So here the answer for this n equal to 30 will be 6. Here I have also performed a dry run here about n equal to 30 example, where we have started from some of the values from 1 to 6, and the moment we got this number 6, so there the condition failed and we just stopped there. So the maximum possible value which we got for this n equal to 30, that is 5, means 5 is the square root of this value n. So this approach works when we are having the smaller values for n, but if let's suppose if the value go for n equal to 10 power 14, then in that case it will go up to 10 million iterations, obviously, and in that case this approach will not work. It will automatically lead to time limit exceeded, and that is not at all acceptable. So we will have to move towards a better approach, and that will be the some approach where it should have some minimum iterations. Now we can we think of a binary search approach in this problem to solve this problem? So now, before thinking about the better approach, that is the binary search approach we are thinking of, that can we apply or not, so before that we should ask some of the questions before this. That first question should come into our mind, that where we will be searching for. Obviously we are not given with any of the array, we are simply having a number, okay, and here n equal to 25 or any of the number, we are only having a number. Where we will be searching for, we are not having the search space, means we are not having the array. Second thing is that if also we are not having the array, so we cannot use any pointers and all in order to find the mid index or something. So we are not getting any of the things here in order to perform the binary search. And here, when the moment the confusion arises in this case, that we are only having such things, only the number we are having for such problems, how will we perform the binary search? This is where the binary search on answer pattern is born. So now, before moving forward, let me just reframe this particular problem a little so that we can have a more understanding about it. So here I have just made a number line here, as we already know that whenever we will be finding the square root of any number n, so that will be ranging from 1 to root n. Like here, now I'm not going to ask you the question that where is the number, because obviously we are not having any of the array in order to find the number and all. So the question which I will be asking is that what is the answer. Obviously if we are having a number n and I'm going to find the square root of n, so what will be the answer? That will be the square root of n only. So if I'm having n equal to 30, so what will be the answer of it? That will be the square root of n. That will be the answer. So we will have to make a few observations here. First of all, if I am trying to, so one thing is clear, that I am not asking that where is the number, I am asking that what is the answer in this case. So if n equal to 30 I am finding for as an example, then the answer will be root n. Now where it will be present, what is the range where it will be present? So some of the observations, the lowest possible value which can be, that will be 1. The answer can't be 0. And second thing, what can be the maximum possible value of the square root of n? That will be, the maximum possible value will be n, which is given to us. This is the range where the square root of n will be available, means it can't be 0 and it can't be more than n. So now we are having the lowest possible value, that is 1, and highest possible value, that is n. Now this is nothing but the range of possible values, which or range of possible answers we can say. So range becomes 1 to n, and which is the search space, and we can also say this is the range of possible answers. So we got the range of possible answers, but as we talked about, that we have to perform the binary search. So before making that decision that we will be performing the binary search on this particular search space, before that one condition should be met, and that is the only condition which is to be met. That is that if we perform the binary search on this range of possible answers, so is it having the monotonic behavior or not? Now before understanding this, we should firstly know that what is the monotonic behavior. So monotonic pattern is nothing but if we are having the numbers from 1 to n, which is obviously we are having this search space 1 to n, and I am saying, just for the sake of understanding, if we are having a mid equal to 1, then I will be checking if this 1 into 1 is less than or equal to 25 or not. If it is, then I can update the answer. So yes, it is true. Then we check for, obviously because we want the greatest possible values, we will be moving forward. Then we check for mid equal to 2. Is 2 into 2 less than or equal to 25? It is yes, it is true. Then we again move forward with another value, so mid equal to 3. Now 3 into 3, that is less than or equal to 25. It is also true. Then mid equal to 4, 4 into 4 less than or equal to 25. That is also true. Then we move forward to have the greater value possible. Then 5 into 5 less than or equal to 25. It is again true. And the moment we moved to mid equal to 6, 6 into 6 less than or equal to 25, that is giving us false. It means this is the first place where the condition goes false. So the thing I am trying to explain here is that for some numbers you will be getting the condition to be true, and after that it flips to false. And the moment it flips to false, that particular situation will remain the same. Means when it flips from true to false, it will always remain false. And in case if it is true, then it will always remain true in that particular direction. So if it is true in this, then it will be remaining true in this particular direction, and if it is false, then it will be remaining false in this direction. So that is the meaning of monotonic pattern. So here we can see the range of possible answers follows the monotonic pattern. Means Once the condition flips to false, it will always remain false. That is the case. So we seen that this particular range of possible answers which we are having, this is following the monotonic pattern, and this is the only condition which it should fulfill. So we got to know that this is having the monotonic pattern and it is following the monotonic behavior. So we can use this binary search on answer on this particular problem. So monotonic, as I have already told, that this is monotonic means once it is false, it is always false, and once it is true, it is always true in that direction. So that's the condition for binary search on answer. And binary search on answer finds the boundary where the condition flips, not a key in an array. Obviously, we are not finding a key in an array. We are not even having the array in this. And so we are not finding a key in the array. Whenever the condition flips, we got the answer there. That we will see more when we solve this problem. Now, one another pillar of this pattern is the is possible function, and we can also say it as the heart of this pattern. So in this series, every problem will be having an is possible function, and which we can also say it as the heart of the binary search on answer pattern. And it will be just taking the candidate answer, means whatever the mid we will be having, we will be finding the mid for a we will be finding the mid for a particular range. That will be, if we means we are already having the low and high, and then we will be finding the mid. Now when we find the mid, then we give that particular mid to the is possible function, and mid is a kind of candidate which we say. So what this is possible function do is that it just asks that is this the answer which is valid, means it is possible, is it possible to achieve this the goal of the problem with this particular value mid. That is the thing it asks. So for example, for the square root problem as we are solving, it will just take this mid value and it will check that is this value possible in order to be updated inside the answer. Let's suppose we are having a particular mid value, and it will check if this mid into mid is less than equal to the n for which we are checking, for which we are finding the square root. So if this condition goes true, then it will say that yes, this is a possible candidate which can be the answer, and it just gives true in that case. So it just does the checking that if this particular mid value can be the answer, or it can be the possible candidate or the answer for any of the problem we will be solving. So there are two separate things. This also we have seen for the as possible, and that we will understand more when we will be solving the problems in this series. So now there will be the two separate things. One is that we are having the is possible function, so it will be using the input, like whatever the input is given. For example, in any of the problem, piles is given, like packages given, cows given, whatever based on the problem that is given, the is possible function will be using that particular input to check the validity, if that particular value, that mid value, is valid or not. And another thing is the binary search, which is performed on the answer space which we are making by ourselves, the answer range which we are defining by ourselves. On that the binary search will be performing to decide where to look next. That's the case. So these two are the separate things, and this is critical to just remember that whenever this possible function will be checking the validity of the value, it will be checking inside in the input array which is given to us, or the input data given to us in the problem statement. And the binary search which we are performing, that we are performing on the answer space, or the search space which we have defined by ourselves, so that we can check that what are the possible values or the possible candidates which can be the answer. So that's the case. Now one last conceptual thing which I want to just explain here, that is the minimize versus maximize. So what happens is that it's a kind of like two sequences are there. One sequence is like for some of the values the condition will be true and then it flips to false, and another sequence is that for some of the values it will be false and then it flips to true. So these are the two sequences. And in this, let's say in the first sequence, what happens is that if it is true for certain values, and then it becomes false for certain values, so it's like when it flips to false, it will always remain false. So let's suppose if you are getting a particular value, if you are taking a particular value mid and you are checking with the as possible function, and it gave you true. For example, let's just take the problem square root problem only. And if you get true, now because you want to find the maximum possible value, so you will be just searching in the right half by eliminating the left half. So whenever you get a particular value as the condition is true for a particular value mid, so you try to search in the right. Okay, so here we are trying to maximize the things. So here we are trying to find the last true here, and when we get the last true, so we just get that answer. That is the boundary case which I have just told you earlier. That is the flip when happens at the boundary. So here we are trying to get the last true by just going to right whenever the condition goes true. And in this particular sequence, whenever you get the condition to be true, because you want to minimize the things, so you start to go left, and by moving left you are just trying to go to the first true, and that gives you the answer at the boundary flip. So you want the first true, so you just go left, and whenever the condition goes true. So that's the case of minimize versus maximize. And these things are just as of now the theoretical, or we can say the conceptual part. Whenever we move to the problems, that will be more clearer. Okay, so now let's get to the implementation part, that how we can implement this solution. So now as we are trying to find the square root of n, so here what we are supposed to do is, first of all, we should ask few questions based on this. So the first question we will be asking here is that what is the answer? Like I am solving this particular problem, but what is the answer I want at the end? What I have to return at the end? So what is the answer? That will be the first question which we will be asking. And now after this, if we got to know that we have to find this answer, that we have to find the square root of n. Now I will have to define a particular search space, or I can say the answer range. So that will be the range of possible answers. Range of possible answers. So as we have discussed earlier, that the range of possible answers in this case will be 1 to n, means the answer cannot be 0 and it can't be more than n. So the range of this range of the possible answers will be from 1 to n. So here we have also defined the search space, means that search space will be moving from 1 to n. That will be 1 to n. And for this as well, that the answer will be the square root of n. Square root of n. So these two questions we have answered. We got that this will be the answer. Now for this answer, what will be the range where I can find this answer? That will be from 1 to n. Also we know, means what is the low value for this? The low value for this is n, 1, and the high value for this is n. So these are the minimum and the maximum possible values we have defined here. Now after this, third thing which is important, that we have this range of possible answers, but is it monotonic? Is it follows monotonic behavior or not? What is the monotonic behavior? Means if I start to check for the particular values, for certain values it is true, and after that it becomes false, or in another case for certain values it is false and after that it becomes true. So it's like whenever the boundary flips, at the boundary, whenever the condition flips from true to false or false to true, it stays the same. That is the monotonic behavior. And we have seen earlier here that whenever we have taken some of the values, it stays false forever. In this case, for this particular problem, for the for this 6, it is false. Now if you take any of the values like mid equal to 7, mid equal to 8, that will stay false forever. So that is the kind of monotonic behavior, and it is following. So we can go ahead in this problem to solve. So we can answer this question as well, that yes, it is following the monotonic behavior. So these are the 3 questions which we have answered, and these all are correct. Like we got the answer, we got the range of possible answers, and after that we also checked if it is following the monotonic behavior. So this is the indication that we can use the binary search on answer approach here to solve this. Binary search on answer approach. So let's just go and code this. So here is the function we are having, the main function, where we have taken the number n, and we have taken we will be taking this as an input, and then we will be writing the function implementation here. So we have to find the integer square root of the number n. For this, First of all, we will be defining the low and high, initializing the low and high. So low will be 1, and high will be small n, where we have taken the parameter. And then we will be initializing this answer variable, where we will be storing our result. So as we have to maximize the answer, means whenever we get a particular number which is less than or equal to that n, so we have to maximize it so that we can get to the nearest possible value, which is the square root of n. So here I am just right now I am just initializing it with low. Now I will be writing the while loop, where the condition will be like low less than equal to high. The moment they crosses, this particular while loop will stop. So here first of all we will have to calculate the mid index. So when you will be calculating the mid, in that case just use the safest formula, that is low plus high minus low by 2. Because in case if both of the values are of long type, then in that case the sum overflow might occur. So this is the safest formula we can use here. So after calculating the mid, we will be just writing a if condition, and in this case, in this we will be just calling this function is possible function. And in this, what we will have to provide, we will have to provide this value n, and along with this mid value. And now once this particular function is called, so let's just write the implementation for this firstly. So bool and is possible function, and it will be taking this value n, so that is int of n comma int mid. So now as I have told that is possible function, its responsibility is to check if whatever the mid we have taken, is this the correct value for being the answer or not. So for that it will be checking, and in this square root problem, what it has to check, if that is less than equal to n or not. So it will just take this mid, and it will check, like it will just return from here that if this mid into mid, if it is less than equal to n, then in that case it will just return 2 from here. Means it will just check this expression, and if it is true, then it will return true directly from here. So if this particular function returns true, this possible function, then in that case we came to know that okay, this particular mid is a right one, a right candidate. So we can just store it inside the answer, and because we got one answer, now we know that this is the condition which became true. Now we want the maximum possible answer, the nearest maximum possible answer. So for that we will take our low and move it to mid plus 1. And else case, what will be the else case? Else case is simple, that if this particular condition if this particular function is false, if it returns false, means for that particular case, let's say for the value 6, that condition goes false. So in that case what we have to do, because it is giving false, it means that that is not the right candidate to be the answer. So we will have to move towards left. So in that case this high will move towards left, and it will go to mid minus 1. And at the end we have to just return our answer, whatever it is stored at the end, that will be the answer. Let's just perform a run here. Here first of all we will have to take input, that is, let's say 5. It is giving the answer as 2, and let's take another value, let's say 25. For this it is giving the answer 5, that is also correct. Let's say we take the number 30, which we have taken as an input. So for this also it is giving us 5. Let's suppose we take 36. So for this is answer 6. Let's suppose we say 37. For this as well, the square root of n will be 6. So this is the implementation which we have seen for this problem according to the binary search on answer pattern. And this is a simple template which will be used, like this function will be used throughout all the problems which we will be solving in this particular series. And more you will be understanding about this when we solve more problems. So here also these can be of long, so it is good to take like long type these values. This also type, take these parameters also as well. Now let's just perform a dry run on this. So let me just take this function implementation from here. Let us perform a dry run. This. This is the function which we have, and now let's take the simple example to perform the dry run. Let's say n equal to 25, and now for n equal to 25, let's just have a search space first. So our search space will be from 1 to 25, and we are initializing this answer with 2 first of all, that is with 1. Now the iteration 1 starts. So for the iteration 1 we just check initially that if this low is less than a high or not. So our low is 1 and high is 25. Low is 1 and high is 25. Initially the low is less than equal to high, so for the first iteration we got this, and we will be finding for the mid index. So mid equal to low plus high by 2, that will be 13. So here we are having a mid index as 13, and then we check for the condition, that is if this 13 into 13, that is 169. 169, if it is less than or equal to 25, so that condition is false. So this condition is false as of now, and because it is false, so now we move towards the else part. If this condition is false, if this particular function is returning false, so we go to this, and high moves to mid minus 1. Now high becomes mid minus 1, that is 12. So now high low becomes 1 and high becomes 12. Now again the mid will be calculated. So for that is for the iteration 2. Now the mid is calculated. So what will be the mid? Mid will be 6. And in this case when this is checked, so that will be 6 into 6, that is 36. Again it is greater than 25, so again the condition goes false. That will be 36, and that is this less than equal to 25, so that again goes false. And once it goes false, again the else part will be executed. So here the high will be moving from this 12 to mid minus 1, that will be 5. And now again the condition is checked, so again we go inside the while loop, and now mid becomes 3, that is for iteration 3. Here the mid becomes 3, and then we check for the value, so that will be 3 into 3, that is 9, is less than equal to 25. So yes, this particular condition is true, so we got this true. So now we got this true, and we will be updating our answer with this. So our answer is now initialized with 1. Now it will be initialized with the value 3. Now we move to the iteration 4, but before that this low will be updated, and it will be going to mid plus 1. So right now the mid is 3 and it will go to 4. Now the low becomes 4 and high becomes 5. Now again the condition is true, so while we will go inside the while loop, and first of all the mid will be calculated. So for that the mid is equal to 4 plus 5 by 2, that will be 9 by 2, that will be 4. So mid is 4 now, and 4 into 4, that is 16. So here 16 is less than equal to 25, so this condition again goes true. And now again because it is true, so answer will be updated with the value updated value, that will be 4. And now the low becomes what? Low goes to mid plus 1, that will be 5. Now low and high are both equal, so again the condition is true. It goes inside the while loop, and for the next iteration, for the fifth iteration, the mid will be calculated, that will be 5. Now 5 into 5, that is 25, less than equal to 25, that is the condition which is true. And if it is true, so we can just update the answer again, that will be 5. And now the low will be also updated, so low will become mid plus 1 now, that will be 6. And when the condition is checked, then the while loop will we will just come out of the while loop. So here what we seen, we just seen that we got the answer. This is the answer, equal to 5 for this particular input, n equal to 5, n equal to 25. So what we just seen from here, that we only use the 5 iterations in this for a search space of 25. Okay, so for n equal to, like, we are having the 10 power 14 value for n, as we seen in the video earlier. Binary search takes only 47 iterations in that case. We are having the n equal to 10 power 14 value, and a linear scan takes 10 million iterations, up to 10 million iterations. That's what the O of log n means in practice. Here we have seen. So you can just notice something very important here, that we have not been given with any of the array or something in order to search on. We are just given with a particular value n, and we just derived the search space by ourselves, and then we like after defining the search space, then we just um, uh, performed the binary search on that search space in order to get the result. So that's what that what something interesting which feels about the binary search on pattern. So this is all about this video. Now I need to tell you something about the next video. Like, we use the square root of n as our example today in order to understand. And you might think that okay, we basically already solved it. What's left for the next video? See, everything is left for the next video. Like, because in the next video, I am just going to ask you something that catches almost everyone off guard, and even people who think they have solved the square root before. So suddenly, what will happen is that suddenly your search space will isn't be the integers anymore, and your mid isn't an integer. Your boundary condition changes. Your loop termination condition changes, and there is a important trick there, that is a precision based stopping condition, and that you have almost certainly never written before. So in the next video we will be solving the integer square root first fully, so that you own it completely. Like, obviously we have solved it here, but again we will be solving it again, so that you own it completely, and then we will be moving towards the decimal square root problem, and I will show you side by side comparison that makes the difference so clearer that you never confuse them again. So here is why the square root problem is the perfect first real problem in this series, because it is having the simplest possible function you will ever write in this pattern. Literally one line that is obviously mid into mid less than equal to n. That's it. So that's also important, because in order to understand the template of the binary search on answer pattern, that how to write it. So I just want you to see the binary search on answer in the most easiest form, in the most stripped down form first, and then like before adding the complexity to it, and then once you see any of the harder problems, that will be nothing but the harder is possible function. So this is all about this video, and here we have a good understanding and a good conceptual clarity on this particular pattern. And from the video 2, which is something from where the real series begins. So till then, just keep learning and keep growing. This is Aditya Patel signing off.